All right, so here we're supposed to write the indicated related rates equation. So we want to have the first equation is f equals 3x. We want to relate df dt and dx dt. Okay, well, that means we're going to take d derivative with respect to t of f, and that's going to be the derivative with respect to t of 3x. We're going to take the derivative with respect to x here so we can get our dx dt, and we're going to take this, and well, this becomes df dt. Now, if we take that with respect to x, well, the derivative of that with respect to x is just 3, and what's left over, then we have our dx dt. And again, we're not going to be doing all the little in-between steps like we saw here. We're going to say, okay, well, now we know that we're just taking the derivative of that goes out in front, and then we have our dx dt after that. And so we're kind of going to be skipping steps as far as writing it all out. But what we know is we're taking the derivative of what's on the right side with respect to, in this case, x, the dependent variable, and the independent variable is the t, and so it'll be 3 times dx dt. Okay, same thing on this one. Now we're going to take the derivative of the left, so we'll get dg dt, and on the right it's going to be dx dt. So well, we could take the d dt of g is equal to d dt of e to the 3x. Okay, well, what do we get? Well, when we get on the left, that just gives us dg dt. So hey, we've got the left part done, equals. Now we're taking the derivative of that. Well, if you remember how to do that, we're going to take, the ln of that, and then we're going to do that. So we're just going to get 3 times e to the 3x times dx dt. So it's just, again, remembering how to take that derivative, and we get this piece, and so then that's times our dx dt. Now, when we actually are working a problem, they might tell us what x is and what dx dt is, or we might have to solve actually for what dx dt is. Sometimes they don't tell us, but we have to, go through and look at the problem, and they tell us two times, and then we just divide them and we get a rate, and we can plug it in, and then we can find what the actual rate for dg dt is. Okay, what about here? Okay, well, again, we're going to look for df dt. Okay, so we're taking the derivative of that side with respect to t. And then this one, we want dx dt, so we're going to take the derivative of that with respect to x and dt. So d dt of f equals d dt of 62 times 1.02 to the x. Okay, so when we take that derivative, we just get df dt. Now, when we take this derivative of this with respect to x, we're going to get 62 times, well, this is b to the x, so that's going to be times ln of 1.02, and then it's going to be times 1.02 to the x, and then it's going to be dx, oops, not dx dt. Okay. So that would then be what our derivative of this one would be. Now, could we simplify? Yeah, we could take that times that, but this is actually a little more exact as far as the number goes, so we don't have to round or anything, and so I would leave it in this format here. All right, so now what do we have on the next one? We have h equals 6a ln a. And if you remember, I had talked about that in the first part. We want to relate dh dy now. Now, we don't always have to have it with respect to time. Maybe it's respect to some y distance, or I don't know what it is. And then dA dy. So with respect to a and the y here. So we're going to have d dy of h, and that equals d dy of 6a ln of a. Okay. Well, this one just gives us dh dy. That's not a problem. Now, if we take the derivative of this one, well, that's, we're going to have 6a times ln of a. So what we're going to have to do is we're going to have to take the derivative of the first, so that's going to be 6, times the second, which is ln of a, plus, and then we have, the first, which is 6a, times the derivative of that. Well, the derivative of ln of a is 1 over a, so that's 1 over a. And now we simplify, so that's 6 ln of a plus, well, that a cancels that, and we just have 6. And so if I was writing it, I would just say, well, this is 6 ln a plus 6, and then I'll have my dA dy, remembering to put it in the proper units, the a and the y, okay? So that's how we do it with the simple problems, and we've taken derivatives before, so that part's not a problem. It's just remembering that now we're doing it with respect to something that's not really there, that dy in this case, or the dt in those other cases. Okay, let's pause there and we'll come back with the application problems.